Hello, my name is Ahmet Selim'inli. Today I'm going to introduce my ECD charge pump project. So in here, my assignment was to get minus 10 volts. So this is my layout and this is my circuit. So as we see, there is 390 ohms of load and I am now getting minus 10.1 volts by giving 6 volts. And so that means it satisfies the first requirement. And for the second one, by the ripple one, I have 64 millivolts. So this also satisfies the requirement, which means we have very small ripple. The upper limit was 100 millivolts. Also, as you see, we have 60 milliamperes of the source current. So we have to calculate the power. So for the source, I have dot 36, and for the output, I have dot 26 approximately watts. So for the efficiency, I have 72%. So this is way higher than 52. So it also satisfies the requirements. Also, I need to show the voltage without the load. So let I remove this one. And I get minus 11.8 approximately, which means it is below than the minus 15. So it also satisfies. So overall, my circuit satisfies all of the requirements that is given in the manual. So let's look to the main logic of the Dixon charge pump. It is very easy and depends on the voltage surge of the capacitors. So let me assume there's 4 manual switches. So firstly, let me close switch 2 and switch 1. So in this case, we have directly 6 volts in the capacitor that is accumulated. Then let me open switch 2 and switch 1 and close now switch 3 and switch 4. Now 6 volts will come in here and we have 6 already in here and we will obtain 12 volts in output. And by doing this one by one, we will have DC 12 volts in the output. So this is the main logic of the Dixon charge pump. So this is the schematic of my circuit. So in here I have 50% duty cycle clock, which gives 0 to 6 volt clock. This is very weak signal. We need to make this stronger. So I use the push-pull driver, which also acts like an inverter. Why we need to make it stronger? Because if we add a load, this voltage drops significantly. So we need definitely a driver. I use another one and connect it to the capacitors. So here, the clock acts like automatic switches, and also the capacitors keeps the voltages. Diodes don't let go to another place. So the voltage is conserved one by one and added to each other. So in here we have minus 2, minus 8, and in the end we have minus 10.1 voltages with 390 ohms. So this is the overall logic of my design circuit. And thanks for listening.